Alright, in this video we're going to be looking at the worksheet that's again under Chapter 2 in D2L called Dimensional Analysis Practice. And what we're going to do is we're going to practice writing out the proper dimensional analysis structure and the way I write it so that it keeps you from making any mistakes, and we're going to do some conversions. So let's start with number 1. Number 1 wants us to convert 261 grams. Remember, we always have units with numbers in science into kilograms. First thing we need to do is we need to get a conversion factor. We need to know how many grams go into a kilogram or how many kilograms go into a gram so we can utilize that in our dimensional analysis. At this point, you should be familiar with your prefixes such as kilo, and kilo means 1,000. So there are 1,000 grams in 1 kilogram. How do we represent that in dimensional analysis? Normally, remember, it is a ratio. So we have 1,000 G all over 1 kg. This is very important. We must be able to set up our dimensional analysis properly so that we can, in fact, get the unit of interest, which in this case is kilograms. So let's write our dimensional analysis in our boxes. We start with what we have, 261 grams, and we make our boxes. Now, remember from our lesson, the units that we start with must be canceled away, so they always go on the adjacent box at the bottom. And the units that we are interested in finding need to go in the adjacent box in the top. If you notice, we have kilograms over grams. Therefore, we can use this ratio here, but we must flip this ratio. 1 kg over 1,000 grams is still a valid ratio. We can still use that. The numbers always move with the units, so we have 1,001. Remember, our operation on the top, the up and down line, that is multiplication, and the horizontal line is division. So we have 261 times 1, which is 261 all over 1,000. Our units that are left is kg. How do we know that? Well, we're getting rid of grams and grams. They cancel because there's one over the other. G divided by G equals 1, so they go away. 261 divided by 1,000 gives us a value of 0.261 kilograms. You can also put your 0 in front as well. So your answer for this problem, this conversion, utilizing dimensional analysis, is 0.261. Let's try another. Number 3. We have 9,474 millimeters, and we want to go to centimeters. Okay, now we need to know our conversion factor. Milli is a thousandth, and centi is 100th. So, in 1 centimeter, there are 10 millimeters. How do we know that? Well, we know that millimeters, milli is 1,000th, and centi is 100th, so they are an order of magnitude away from each other, which is 10. 1 decimal place away. Therefore, since we know that our conversion factor is then 1 centimeter for every 10 millimeters. Now we set up our dimensional analysis, 9,474 millimeters. We set up our boxes. We have 10 millimeters for every 1 centimeter. This is equal to 9,474 all over 10. The unit that we're left with is centimeters, and that is going to equal us to 947.4 millimeters. Notice I have my units and I have my number to the proper number of decimal places and the proper number of significant figures.